Okay, today we're going to be talking about chapter 1, pure mathematics 1, which is about coordinate points and line. On this chapter we have several objectives. For example, the first one, we define the distance between 2 points, find the midpoint of a line segment, and given the coordinate of the point. Find the gradient of a line segment, the equation of a line through given a point and given a gradient. Find the equation of the line joining 2 points. Recognize lines from different forms of the equation. Find the point of intersection of 2 lines. And finally, we will see how the gradients, we can have 2 different kinds of gradients if they are parallel or perpendicular. Okay, we're going to start with the distance between 2 points. If you see this example, on the coordinate plane we have the y-axis and the x-axis. It's important for you to remember that over here we have the negative y, and over here we have the negative x. Over here we have 2 points, point 4,3 and 10,7. How do we know what is the distance from 4,3 to 10,7? We can use the distance formula. And in order for you to use the distance formula, we have to recognize on each of these 2 points which one is your x1, your y1, x2, and y2. You also can do the opposite. You can name these x1, y1, x2, y2. Remember, we are finding the distance from this point to this point. Okay, distance will be the square root of the subtraction of my x. x2 minus x1, that will be 4 minus 10 to the second power plus 3 minus 7 to the second power. So 4 minus 10 will give me minus 6 to the second power, and over here minus 4 to the second power. This is 36 plus 16. And that will give me the square root of 52. So if you want to, you can find an approximate, because this doesn't have a perfect square root. So you find the square root of 52, which is approximately equal to 7.21. Okay? We have, you see, one more time, we can say that from here to here, we have a distance of 7.21. Okay, now we have section 1-2 on the chapter 1, which is the midpoint of the segment. So we have this formula. What do they mean by that? We have exactly the same problem that we spoke about it before with the same point, 4,3 and 10,7. How do I know which one is half of that line? We can use this formula right here. So what we're going to do again, x1, y1, x2, and y2. Over here what we will do is add the 2x, that will be 10 plus 4. We will divide it by 2, comma, and we will add the 1, that will be 7 plus 3, and we will be divided by 2. Why are we dividing by 2? Because we are looking for midpoint, I mean half of the segment. So this is equal to 14,2, and over here 10,2, and this is equal to 7,5. Okay? So when we have this, if you see, you count 1, 2, 3, 4, 5, 6, 7. That will be over here. And then we count 1, 2, 3, 4, and 5. So that means that the midpoint of this specific segment is 7,5. Okay. On section 1-3 from chapter 1, we will see the gradient of a line segment. When we talk about gradient, talk about the slope of the line. We talk about the steepness of the line. Okay? So it is simple. The formula for this is usually represented by an M. M most of the time represent what we call gradient. And it is the subtraction of the y divided by the subtractions of the x. Okay? Over here, you see we have the same example from the two previous ones. We have 0.43 and 10.7. And I want to know the steepness of this line. We can do it geometrically, and we can find 1, 2, 3, 4, 5, 6. And over here, 1, 2, 3, and 4. We will see that later. We will do it over here with the formula. This is x1, y1, x2, and y2. Okay, we subtract 3 minus 7 divided by 4 minus 10. That will give me minus 4 divided by minus 6. Negative and negative is positive 4, 6. If we simplify here, I will get 2/3. What I was telling you before is that you see, when we're talking about a steepness, it's the rise divided by the roof of the line. We count 1, 2, 3, 4. Over here is 4. And over here will be 1, 2, 3, 4, 5, 6, which is 6. So that will be 4 divided by 6. I'm going to open a parenthesis here just to let you know that every time we have a line like this, the gradient of the slope will be always positive. If we have the line coming like that, we will have a negative gradient. If we have a horizontal line, the slope will be 0, and it's completely vertical. There's no slope or undefined. We must remember that when we have two parallel lines, the gradient of these parallel lines will always be the same. That's something that you must remember. Why? Because they will keep the same steepness and they will never intersect each other. That's why two parallel lines will always have the same gradient. Over here we have an example, and it is a quadrilateral. They are asking us to prove if this quadrilateral is a parallelogram. Parallelogram. What does that mean? That the opposite side must be parallel. And what did I say previously? That if we have two parallel lines, the gradient must be the same. So what we're going to do is we're going to find this slope over here. Let's call it M1 and M2, which are the opposite. If we have them parallel, that means if we have the same gradient, that means that they are parallel. And let's call this M3 and this M4. If this M3 and M4 are the same, that means that we have a parallelogram. If that does not happen, we are talking about a quadrilateral, which is not a parallelogram. Let's start with M1. Remember that the formula for the slope is y2 minus y1 divided by x2 minus x1. Okay? So that will be, let's call this x1, y1, x2, y2. 3 minus 1 and 5 minus 1. So that will be 2 over 4. If we simplify, we have 1/2. Okay? Now, let's proceed to find M2, the opposite side of M1. Okay? Let's call this x1 and y1, x2 and y2. So that will be 0 minus minus 2 and 3 minus minus 1. That will be 0 plus 2 and 3 plus 1. So this is 2, 4, and when we simplify, this is 1. Until now, we have proved that these two are parallel. What is missing is that we have to prove that this and this have equal slope. So let's do n4 and n3. N3 will have x1 and y1, x2 and y2. So that will be equal to 3 minus 0 and 5 minus 3. So this is equal to 3 divided by 2. So that over here I have a slope of 3 half. Let's find n4. This is x1, y1, x2, y2. So that will be equal to minus 1, minus 1, minus 2, minus 1, divided by minus 1, minus 1. This is minus 3 divided by minus 2, and negative divided by negative is positive, so this is 3 half. So bingo! This side and this side of this quadrilateral have exactly the same law. So these two are the same and these two are the same. So this is a parallelogram. And we have proved that the quadrilateral is a parallelogram.